So, last time we have discussed the payoff matrices, and we really explained what is a payoff matrix, which has on one side the states of nature on which the decision maker has no control, on the other side are the decision alternatives which the decision maker can actually control. Now, in order to evaluate the payoff matrices, we have to really know the different types of decision maker. You see that first of all, this is really the explanation of the payoff matrices. The states of nature and the decision strategies may or may not be known with certainty. The probabilities of occurrence of outcomes may also be not known, and decision analysis therefore may be a combination of decision making under certainty as well as uncertainty. So, these are the different types of decision makers you can tell, or you can tell the decision making criteria, and we shall explain each one of them, but in the very first slide let us see what are the different criteria about decision making. The first one is the Maximax or the Optimism criteria. The second one is the Maximin or Pessimism criteria. The third one is a combination of both optimism and pessimism, that is called the Hurwicz or the criteria of realism. The fourth one is Laplace or equally likely criteria, and finally the Savage or Minimax regret criteria. So, all of these 5 different decision making criteria, let us evaluate and see the details. The first one, which is known as the Maximax or the optimism criteria. You see, a Maximax operator or a kind of decision maker who actually is really goes for optimism. What are the conditions which makes a person really go for the optimism criteria? If I really try to look at the different kinds of decision makers, we shall find that there are certain kinds of decision makers who really have very little options. The example can be taken, let us say, from the transport business. Transport business is such a business where the profit margins are high, maybe 20 to 25%, but the uncertainties are also high. When you have a certain number of trucks, it is imperative that you are also should be ready with uncertainties or disruptions in the business. That means there could be an accident, the truck may not be operating due to certain situations, or there could be certain maintenance problems, or even there could be some other kind of problems like some legal problems or any such problems. All of these really makes the truck business a little uncertain. Suppose a person who has bought only one truck, he has just one truck, and as long as the truck is moving properly, there are no accidents, there are no difficulties, everything is fine, then he does a very good business. But moment the truck faces with some eventuality, that means there are some accidents or the truck is under maintenance, then the business is not doing well. So, in this situation the person probably has very little option but to become an optimist. The optimist, because he thinks that nothing is going to happen, everything is all right, and therefore the business will go on. Putting in a different language, let's look at this particular problem once again, and if you look at the various states of the nature, there are 3 possible changes. One is no market change, favorable market change, and unfavorable market change. Here the Maximax operator, who really believes in optimism, would like to think that the best state of nature would occur for whatever decisions he or she may take. For example, if the person is going to really take the redesign as an option, then what would be the state of nature? that he would really assume? He would assume really that the favorable market changes would occur, and therefore, his payoff, if you really look at here, the payoff Maximax, if I write here a Maximax operator, the Maximax operator payoff would really become 100. Why 100? Because the Maximax operator thinks that the best state of nature would happen for a particular decision. So, if he goes for redesign, the best possible state of nature is favorable, because out of these 30, 100 and minus 80, 100 is the maximum. So, maximum payoff the person may get is 100. So, by similar logic, if we really go for the second decision alternative, that is, if the person really goes for refurbish, then again similar kind of thing may happen. The person again would believe that favorable market changes would happen, because that is about the optimism or Maximax criteria, that if you go for favorable market changes, then the maximum payoff is going to result. So, if he goes for refurbish, then the decision really would be 200, that will be our payoff, and therefore, that would be the payoff for the second decision alternative, that is the refurbish. The third one, when it comes to do nothing, again by same logic, the payoff would be 30, because that is the best possible payoff horizontally that the person would expect, because the person thinks that the best possible states of nature would occur for this particular decision alternative. So, we have got these three Maximax payoffs, 100, 200 and 30, and since 200 is maximum, we would assume that this would be the payoff. Why this would be payoff? Because the Maximax decision maker would then go for refurbish. Why refurbish? Because out of the different payoffs that the Maximax operator can have, that is 100, 200 and 30, 200 is maximum, and therefore, a Maximax operator would really like to go for the refurbish option. Now, let us come to the second one, which is known as the Maximin operator. The Maximin operator would find the minimum possible payoff for each decision alternative. Select the decision alternative with the maximum of the above maximum payoff. So, I am sorry, this is select the decision alternative with the minimum of this, because it should be the minimum of the above maximum payoffs, right. So, instead of this one, that select the decision alternative maximum of the above minimum payoffs, right. So, find the minimum possible payoff for each decision alternative and select the decision alternative with the maximum of the above, not maximum, but minimum payoffs. So, let us go back and let us try to see what is there for a Maximin operator payoff. So, Maximin operator, what would be the payoff? So, for a Maximin operator, the person is pessimist. Because of pessimism, it would be like thinking that for every decision alternative, the worst state of nature is going to happen. So, out of, say, let us say the person goes for redesign, then what are the payoffs? The payoffs are 30, 100 and minus 80. 30 for no market changes, 100 for favorable market changes and minus 80 for unfavorable market changes. Out of these, the worst payoff is minus 80. That means, if the person is a pessimist who thinks that worst is going to happen, he or she would really go for the redesign alternative and expect a payoff of minus 80. Why? Because that is the worst payoff. In similar logic, if the decision alternative is refurbish, again the worst state of nature is unfavorable market changes, and in this case the payoff to expect is minus 200. And when it is do nothing, out of the 3, 0, 3 and minus 50, the expected payoff would be minus 50. Now obviously it is a Maximin, that means maximum of these minimum payoffs. So which one is the maximum of these minimums? That is minus 50, because others are even lower, that is minus 80 and minus 200. So in this case the decision of the decision maker would be do nothing for Maximin, and the payoff expected would be minus 50. So this is for the Maximin operator. So we have the Maximax operator, where the operator would think the best possible situation will result, and whereas for Maximin the expectation is the worst possible payoff would result. However, in real world we really do not always get an optimist person or an out and out pessimist person. We get a person who is a combination of the Maximax and Maximin, or in other words a person who is optimist but to a degree, and that is where we have the Hurwicz criteria. So Hurwicz criteria basically says that choose a degree of optimism, let us call it A, obtain maximum payoff max and minimum payoff mean for each decision alternative, and then obtain Hurwicz payoff for each strategy as A into max in plus 1 minus A star mean. That means select the decision alternative with the maximum of the above Hurwicz payoffs. So supposing let's take a particular case for Hurwicz, that we have to have a certain value for a Hurwicz operator, right. So let us take an A value of say 0.4, right. So what is 0.4? The 0.4 can be called as the degree of optimism. So we can write it here, the degree of optimism. The degree of optimism A equal to 0.4. So the degree of optimism is 0.4 and is the Hurwicz operator. So basically what it means? It means the person is 40% is optimist and 60% pessimist. So if that is so, then an optimist, if he goes for redesign, expects a payoff of 100, a pessimist would like to have a payoff of minus 80, because the pessimist would believe that worst state of nature would happen, but the person who is, let us say, 40% optimist and 60% pessimist, what would be the payoff? The payoff would really be 40% of 100 and 60% of minus 80. So 40% of 100 is 40 and 60% of minus 80 is minus 48, right. So minus 80 into 60 means 0.6 is minus 48 plus 40. So the Hurwicz payoff will be minus 8. How we get minus 8? 100 into 0.4, that is 40, right. We can write it somewhere here, 100 into 0.4 plus minus 80 into 0.6, right. So that is 40 minus 48 equal to minus 8. So this is how we get the Hurwicz payoff. It is a combination of the Maximax and Maximin. Let us for second, let us assume that the degree of optimism is 0.5. If the degree of optimism would have been 0.5, then the value would really be 100 into 0.5 plus minus 80 into 0.5, that means 50 and minus 40, right. So, let us do once again 100 into 0.5 plus minus 80 into 0.5 equal to 50 minus 40 equal to 10, right. So, and Hurwicz payoff would have been 10 if the degree of optimism would have been 0.5. That means, the person is equally likely to be, it is exactly in between optimism and pessimism. Very simple terms, 100 plus minus 80 by 2, that means 20 by 2 equal to 10, right. So, I think now it is very clear that if the degree of optimism is low, the less weight will be to the optimist value and more weight will be pessimist value. Whereas, if the degree of optimism is let us say equal, then it will be simple average between the two. Now, the next thing, that is your second decision, refurbish. So, again we have seen the Maximax payoff was 200 and Maximin payoff was minus 200. So, again if we give 40% weight, then 200 into 0.4 it will be 80 and minus 200 into 0.6 will be minus 120. So, on one side we have 80 and other side we have minus 120. So, it will be minus 40. That would be the Hurwicz payoff for the second decision, refurbish. The third decision alternative, that is do nothing, again we have seen the Maximax payoff is 30 and Maximin payoff is minus 50. So, again by the same logic, minus 50 into 60%, that is minus 30, and 30 into 0.4 is 12. So, 12 minus 30, so it comes to minus 18, right. So, 30 into 0.4 12 minus 50 into 0.6 is 30 minus 30. So, 12 minus 30 minus 18. So, these are the Hurwicz payoff we have got, minus 8, minus 40 and minus 18, right. So, once we have got all these three Hurwicz payoffs, we can see again the maximum of them. Which one is maximum? Minus 8. So, we go for this particular payoff and the person may really go for redesign, right. So, person if he is a Hurwicz operator of alpha equal to 0.4 would expect a payoff of minus 8 and go for redesign. The next one is, which is known as a Laplace operator. The Laplace operator would find the average value of payoff for each decision alternative. Select the decision alternative with the maximum of the above maximum payoff. So, basically you see what really happened in a Laplace decision maker. The Laplace decision maker really would think that there are some probability associated with the different states of nature and all these probabilities are equal, right. So, a Laplace operator would assume equal probabilities. See, real probabilities are not known, are to be estimated. So, initially we are thinking it is like a certain kind of uncertainty situation, and since the probability is not known, we assume the probabilities are equal. That means probably 0.33, 0.33, 0.33 around that. But then again we need not really write those probabilities, because if they are equal probability, then what would happen, basically if we multiply by the same probability, then virtually it become taking an average of the three numbers, right. So, what would be the Laplace payoff if the person goes for redesign? It will be the average of 30, 100 and minus 80. So, 130 minus 80, that is 50. The Laplace payoff in that case would be 50 by 3, right, because 30 plus 100, 130 minus 80 is 50 divided by 3. that will be the average of the 3 payoffs. Similarly, if it is refurbish, it will be 50 plus 200 minus 200, again it will be 50 by 3. And the last one is 0 plus 30 minus 50, it is coming to minus 20 by 3. So, what would be the decision of let us say the Laplace decision maker? The Laplace decision maker would really go for redesign or refurbish, both are equally likely. So, in this case the Laplace operator would really go for either redesign or refurbish, because both are having equal probability. So, we have seen that depending on various decision operator, that whether it goes for Maximax, there will be a payoff, Maximin, there will be another payoff, the Hurwicz, there will be another payoff, and Laplace is having another payoff. So, what is very interesting to note is that even for a simple payoff problem that we have taken up here, that the decision is changing, that means which decision alternative a particular operator would really like to go for is changing based on what is the kind of decision maker. A Maximax decision maker goes for refurbish, a Maximin decision maker goes for do nothing, a Hurwicz decision maker goes for redesign, and a Laplace decision maker makes equal choice between redesign and refurbish. So, in all of these basic question comes back, that what is known as rational decision maker. Who is a rational decision maker? Is a Maximax decision maker a rational decision maker? Is he she taking a rational decision? Probably no. And what makes someone really go for a rational decision making? It is a very important question, and the answer really lies in understanding what is happening in the transport business. Let us go back to there one more time. You see, a particular person has gone for a transport business, and if the person has only one truck, then sooner or later he may go out of business. Why? Because just with one truck, sooner or later it will have some kind of eventuality, either accident or maintenance problem or legal issues, and therefore the business may not continue. But imagine if a person is having 100 trucks. If the person is having 100 trucks, there is always an expectation that out of these 100 trucks, some will be under accident, some will be under maintenance, some will have legal issues, but the rest of the trucks, maybe around 90, would be operating. So, what will happen? The person therefore will say that these are the probabilities, that 90 trucks would be available, some will be accident, some will be under maintenance, some will be under legal issues, and therefore the resultant profit or the resultant payoff would depend on such probabilities, right. So, basically therefore a person can become rational only when there are opportunities to really cater to all of these. You see, alternate situations can result. A person can have one truck, but like that 100 people also can have one truck each. They can either go for insurance or they can go for what is known as a cooperative. Suppose 100 people forms a cooperative, then it is like the cooperative is having 100 trucks, and these 100 trucks are basically one truck each for 100 people, but they have gone for a cooperation, and this particular cooperative is having 100 trucks, again 90 would operate, but the profit will be shared by the cooperative. Even if a few trucks are under difficult situation, the cooperative can still be in business and doing well, right. So, basic point here is a person will become rational operator only when there are situations where the portfolio is basically obtained. right. So, and that portfolio would be has to be created. Let's really look at how exactly these things are happening. So, basically, so when it comes to that kind of situation, we call what is known as the expected value approach, also known as the expected monetary value approach. So, either we call it the so called expected value approach, or sometimes we can also call it as a rational decision maker or an expected monetary value. So, under all of these situations, so there would be probability of occurrence for each state of nature, and find the expected value for each decision alternative as the sum of pi into p of I for all the states of nature, and select the decision alternative with the best expected value. So, essentially what is the process? The process is that we put specific probability values for each specific payoffs. We calculate the expected value of the decision alternatives, and finally we find out which decision alternatives are coming out with a best expected value, right. So, all of these things we shall discuss in our next lecture. Thank you very much.